Hello everyone, welcome to my channel. Today we are solving cloneGraph, which is LeetCode question number 133. So for this problem, we are given a reference of a node in a connected undirected graph, and we're going to return a deep copy or clone of the graph. So for each element, we are going to represent it with a node object, and it's going to have a val variable, which is the value. And we're also going to have a list of its neighbors. So for example, for the node 0 in this example, we're going to have a value of 0, and we're going to have the list of neighbors, which is going to be 1 and 2 in this case. So whenever we need to clone nodes, either graph or in linked lists in other problems, we need to somehow connect the original node and its clone node. So to do that, we're going to need a data structure that keeps track of two elements at once. So what we can use is a hash table. And in Java, it's going to be a HashMap. And the HashMap has key and value pairs. And the key is going to be the original node, and the value is going to be the clone node. So for this example, on the right, we can have a key of 0, which is the original node. We can have its clone node 0 in the value. And same as 1, original node in the key, and the clone node in the value. So why do we use HashMap? When we are connecting clone nodes after we create them, we can use HashMap to find which nodes are the neighbors of the clone node. And we're going to look at this later in the example as well. So for this problem, we're going to use a depth first search. And those are the steps, and we're going to go through these steps one by one with an example. First thing we're going to do is to create a hash map. And again, the hash map will have a key of original nodes and the value of clone nodes. And we're going to use this example of a cloneGraph function with the argument the node 0. And in Java, creating a hash map will look like this. Next, we're gonna do an operation for each node. We're gonna start with the node 0 in this graph. We're gonna check if the node is null. It's not null, so we're gonna put the node and its clone to the map. So we're gonna put the node 0, original node 0 to the key, and we're gonna create its clone, orange 0. We're gonna put it in the value of the hash map or key value pair. And in Java, it's going to look something like this. And next, we're going to do an operation for each of the neighbor of the node. In this case, 0's neighbor. The 0's neighbor is 1 and 2. So we're going to start with the neighbor 1. And we're going to check if neighbor 1 exists in the hash map. In this case, it doesn't. So we're going to call the function again with the neighbor 1 to create its clone. So I made this recursion map to keep track of all the recursive codes because it can be a little bit complicated. So we first started with the original function cloneGraph with the argument 0, and then just now we called the function again with the argument 1 because 1 was 0's neighbor. We're going to start from step 2 again. So check if the node is no, it's not no. So we're going to put the node, in this case 1, and its clone node to the map. So we're going to put the original node 1 to the map, to the key, and the value is going to be the clone node that we created. And then we're going to check 1's neighbors this time. 1's neighbors are 0 and 3. So we're going to start with 0. And we're going to check if it exists in the hash map. In this case, it does. So we don't have to code the recursive function. So we're going to skip this step and we're going to go to step 2.4, which is update 1's neighbor. And now we know that the clone node 0 exists. So we can add 0 to 1's neighbor like this. And in Java, it's going to look something like this. It looks a little bit complicated. So I'm going to go through one by one. So map.get of node will get the clone node of the current node, which is 1. So it will get the orange 1 node. And then neighbors.add will add whatever is inside the argument to the neighbors. Map.getNeighbor will get clone node of the neighbor, which is 0. So we can add 0 to the neighbor list of 1. And we're going to check the other neighbor of 1, which was 3. And we're going to check if it exists in the hash map. It doesn't. So we're going to call the function again with node 3 to create its clone node. And we're going to start with step 2 again. It's not null, so we're going to put the node and its clone to the map. We're going to check 3's neighbors again, which is 1 and 2 this time. We're going to start with 1 this time. And 1 already exists in the hash map. So we can just update 3's neighbor. We can add 1 to this 3's neighbor. And I'm also using half a line here because I'm only saying that 1 is 3's neighbor. I have to say 3 is 1's neighbor to complete the line, and I can do that later. Alright, and I'm going to check 3's other neighbor, which was 2. And it doesn't exist in the hash map, so we're going to call the function again with node 2. We start from step 2 again. We'll put the node and its clone to the map, so this time 2 and 2. And we're going to check 2's neighbors, in this case 0 and 3. They both exist already in the hash map. So we can just update 2's neighbor. We can add 0 and 3 to 2's neighbor, like this. And after that, we're going to reach the end of the function. So we're just going to return the clone node. In this case, currently we are at 2. And we're going to go back to the previous recursive call, which is cloneGraph 3. We stopped at step 2.3, so we're just going to continue at step 2.4, which is to update 3's neighbor. We're going to add 2 to 3's neighbor using the hash map. And then we'll reach the end of the function again, so we'll just return the clone node, which is 3 in this case. We'll go back to the previous one, which is cloneGraph 1. We'll continue from step 2.4 again, so update 1's neighbor, add 3 to 1's neighbor. We're just going to return the clone node 1. We'll go back to the original function, cloneGraph 0. And lastly, we now know the clone node 1 and 2, which is 0's neighbor. They both exist, so we can add them to 0's neighbor. And lastly, we're just going to return the clone node, which is 0 in the original function. And that's how we clone a graph. It seems a little complicated, but code is a lot easier than you think. So you can check out this video right here. If you want to see the code solution, you can click on this next video or click the link in the description. Thank you for watching.